We have this problem, maximum depth of a binary tree. So we are given a root of a binary tree and we need to calculate the maximum depth. What does it mean by maximum depth? So by maximum depth, it means that the number of nodes along the longest path from the root node to the farthest leaf node. This is the root node and this is the farthest leaf node. So the depth of this binary tree, the maximum depth of this binary tree would be this one and this two, which is equals to the length of these edges. So how do we solve this problem? We can use depth first search over here. What we would do over here is, using depth first search, we would go deep inside the tree and from every stage we would return the height. From 7 we can return the height after 7, which is 0. Over here 20, this node would add 1 to it, which is because of this edge. So this 20 would return 1 plus 0, and that would be 1. This 3 would return from our function and it would return 1 plus this edge, which would be 1 plus 1, 2. And we have an answer. So how do we implement it in code? Let's take a look. So we are here in the code editor. We have a function max depth. We have root. The first thing I need to do is find out the maximum depth in the left subtree. L would be equals to, I can call this function max depth for the left subtree. I can do the same for the right subtree. This would give me the depth in the left and the right subtree. I can return that. I can get the maximum of left and right, and I need to add plus 1 to compensate for the edge because I'm getting an answer from over here or from over here, and I need to compensate for this edge which is getting added, so I can add plus 1. We also need to take care when we do not have root.left or root.right. For example, on the leaf node, the left and the right are none. So we need to handle that. So we can say if not root, we need to return 0 from over here because the length after this is 0. Let's try to run this code. Let's submit it. We have a solution.